Right, so let's do our exponent and logarithm review or practice. And it does ask you to do this without a calculator. So we're going to try and do it without a calculator. This first one says 27 to the 1/3. And remember that we always have power over root. And when you're doing it without a calculator, always start with the root, then do power. Okay? Oh, sorry. Without a calculator, always start with the root and then do power. So root, then power is the order that you want to do it when you don't have a calculator. So 27 to the 1/3 means the cube root of 27, which I know is 3. 3 times 3 is 9, 9 times 3 is 27. For number 2, because I want to start with the root, then do the power, I'm going to do the square root of 9, and then I'll cube that. Well, I know that the square root of 9 is 3, and then I know that 3 cubed is 27. Alright, let's go to number 3. Again, like I said, always do root, then power. Square root of 4, and then raise that to the 5th, which means I'm going to take 2 and raise it to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Right, number 4. 2 to the negative 3rd. So I don't like that negative, so I'm going to move it to the bottom here, and it's going to become 1 over 2 to the 3rd, or 1 over 8. Because 2 times 2 is 4, times 2 is 8. Right, 4/9 to the 3/2 power. Remember, always start with root. So the square root of 4/9, and I'll cube that. Well, I know that the square root of 4 is 2, and I know that the square root of 9 is 3, because I can think of this, when it's the square root of a fraction, as the square root of 4 over the square root of 9. And now I have to cube that 2/3. When I cube the 2, that's 2 times 2 times 2 is 8. And then when I cube the 3, 3 times 3 times 3 is 27. Right, number 6. 1/8 to the negative 1/3. I do not like that negative. So remember, if I cross the line, it changes the sign. So I move the 8 to the top and the 1 to the bottom. I get 8 to the positive 1/3, which means take the cube root of 8. Cube root of 8 I know is 2. Number 7. Root equals x, so I have 3 to the x equals 27. I know that it's 3 to the 3rd power, so I know that x equals 3. Number 8, there's no base, so I know that the base has to be 10, equals x. So 10 to the x equals 10,000. I can simply count my zeros. X equals 4. 10 to the 4th would be a 1 with 4 zeros, or 10,000. Right, number 9. 5 that equals x. 5 to the x equals 625. Well, let's see. 5 times 5 is 25. Times 5 is 125. Times 5 gives me the 625. So x equals 4. Let's go to number 10. Equals x. So I have 9 to the x equals 27. Well, 9 times 9 is already 81. So I know I can't write 27 as a power of 9, which tells me I need to rewrite these with the same base. So I'm going to come over here to the left. I'm going to rewrite the 9 as 3 squared to the x. And I'm going to rewrite the 27 as 3 cubed. Power to a power, we multiply, so 3 to the 2x equals 3 to the third. Notice they have the same base, so I can set the exponents equal to one another. 2x must equal 3, so x equals 3 halves. That's my answer for number 10. So x equals 3 halves. Let's do number 11. Equals x, so 4 to the x equals 32. Let's see, 4 times 4 is 16, and then 16 times 4 is 64. So I can't just write 32 as a power of 4, so I need to find a common base. I'm going to use 2. So I have 2 squared to the x equals, I know now that 2 to the 5th is 32. We did it right up here. And power to a power we multiply, so 2 to the 2x equals 2 to the 5th. They have the same base, so I can set my exponents equal to each other. 2x equals 5. So x equals 5 halves. X equals 5 halves. Alright, let's go to number 12. Alright, so for number 12 equals x, so 2 to the x equals 1/8. Well, I can see right away I've got to move this up to the numerator. So 2 to the x equals 8 to the negative 1, because I need everything up here. And I'm going to figure out what I need. These can both be written as a power of 2, so 2 to the x equals 2 cubed to the negative 1. They have, well, I'm not going to say they have the same base yet. I'm going to get rid of those parentheses. 2 to the x equals power to a power you multiply. Now they have the same base. So x equals negative 3. Write that right here as well. Right, number 13 equals x, so 300 to the x equals 1. Well, anything to the 0 power is 1, so x equals 0. Okay, let's do number 15. Sorry about this big thing here. I got rid of it on the copy I have in OneNote this year. So equals x, so 25 to the x equals 1/5. Don't like that 5 in the denominator, so I'm going to move it to the top. So I get 25 to the x equals 5 to the negative first. So I'm going to write these both as a power of 5. 5 squared to the x equals 5 to the negative 1. Power to a power we multiply, so 5 to the 2x equals 5 to the negative 1. Notice I have the same base. Therefore, let's see, 2x must equal negative 1, so x equals negative 1/2. X equals negative 1/2. to 16. 2 to what power is 16? I know that that would be 2 times 2 is 4, times 2 is 8, times 2 is 16, so x equals 4. 17, notice, though it's written different than 15, comes out to 25 to the x equals 1/5, 25 to the x equals 1/5. So this is the same problem as 15, so I already know my answer is x equals negative 1/2. And then 19 here, 3 to the 4th power equals x. So I just need to multiply 3 by itself 4 times. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. And that's it for that worksheet.